Okay, so now I want to show you guys how to do a system of equations by using Gaussian elimination. But this time we're going to do with 3 equations, 3 unknowns, which will be a little bit more work, but at the end of the day, it should end up being sort of a nice little example for you to refer to. Just like before, we're going to start with a matrix. So we're going to change this into, put the system into matrix form. 226, then 8, 4, 5, and 18. So we just converted all the coefficients into the matrix. Now, remember, for Gaussian elimination, our goal is to get it into into reduced echelon form. And that means we're going to have diagonals of 0, I mean, sorry, 1, and the left bottom corner of zeros. We're going to have a number here, number here, number here, and a number here, here, and here. I'm just going to put little dots there to save me from writing a number sign. So it's going to take a little bit more work this time to get from, instead of the 2 by 2 that we did before. So first thing we need to look at is to create this 1. Now, if we look at the first row, we have a 3. Now, in your head, you could go, okay, I can make that a 3 by dividing by 3 or multiplying by 1/3 to be fancy. But we're going to basically, if we try to divide everything by 3, what happens is you have 3 divided by 3 is 1, then you have -4/3, 1/3, -13/3. Those are all going to be fractions. And we sometimes run into fractions when you do systems or you use Gaussian elimination, but you want to try to avoid fractions as much as possible. If you take a look at the second row, you notice you have 2, 2, -2, -26. Well, that's a big red flag. If I divide everything by 2, we'll get integer values, which is a lot easier to work with. Now, I'm not saying fractions is a bad thing to work with, but you want to try to avoid using fractions for at least as long as possible. So what I'm going to do is we're going to use one of the elementary row operations, and we're actually going to switch row 1 and row 2. Right? And the reason is because I know I can divide that second row easier than I can divide the first row. And later on, you'll see us using some fractions. So we're going to do 2, 2, -2, -26. 3, -4, 1, -13. And you have 8, 4, 5, 18. Okay. So right now we have this 2, 2, -2. I'm going to make this 2 into a 1. So I'm going to multiply row 1 by a half. Remember, you can't, even though you're going to really be dividing, division doesn't exist in matrices. So you can only really multiply by the reciprocal. Now, to reduce this, to multiply everything by 1/2, we're going to get 1. Sorry about that. 1, 1, -2, -13. And sorry, I'm running out of room a little bit. Then the next one we're going to keep the same. So 3, -4, 1, -13. And then we have 8, 4, 5, 18. Now, just to fix something, because I made a little mistake, and I did this before, instead of, it's -2 times 1/2, which gives us 1, -1. Sorry, fix that little mistake. Okay, so we now have that 1 there, so we're done with that. Our next step is going to be to take these two, 3 and the 8 here, and we're going to make them into zeros. And we can do that easily by using the first row, because we have a 1 there. So you just basically take the first row, multiply it by a constant, and then subtract the second row, and then multiply it by a constant, subtract the first. So what I want to show you, and we're just going to do this separately, you're not going to actually touch row 1 at all. I'm just going to rewrite row 1. Normally, I would advise you to do this all at once because it's really not that bad to do. But we're going to do everything step by step. So we're going to rewrite out the first row. Now, to get this 3 into a 0, we need to take the first row, multiply it by 3, 3 times row 1, subtract row 2, and we're going to put that new answer into row 2. So we're going to take the 1 times it by 3, so 3 times 1 minus 3 gives us 0. 3 times 1 is 3, minus negative 4 is 7. And 3 times negative 1 minus 1 is negative, 3 times negative 1 minus 1 is negative 4. And then 3 times negative 13 minus negative 13 is negative 26. Okay, and you can put that all right into your calculator. Okay? Now, to get rid of this 8 here, because now we want that to become a 0, we're going to do our second operation. We're going to do 8 times R1 minus R3, and we're going to put that in R3. Now, these are just examples of what you can do both these operations. You can switch them around a little bit. You could have done negative 3R1 plus R2. You could have done R2 minus 3R1. It doesn't really matter as long as you make this a 0. Okay? Now, for this one, we're going to do 8 times R1. So 8 times 1 minus 8 is 0. 8 times 1 minus 4 is 4. 8 times negative 1 minus 5 is negative 13. And then 8 times negative 13, 8 times negative 13 minus 18 is negative 122. Okay. Sorry about that little noise. Cell phone going off. Okay, so what we're going to do now is we are going to, well, we have those zeros, so we're good with that. Now our next step is to make this second row, second column, a 1. So now that's 7, we need to make a 1. Now, this is where you could look at this, go, if I divide everything by 7, it's not going to come out to be a nice number. Let's look at the other row. 4, negative 13. If I divide everything by 4, it's not going to become a nice number for these two. So at the end of the day, it comes down to, we could switch them, but you're going to end up having to work with fractions. We avoided it for this long. Yeah. So what we're going to do is we're going to multiply row 2 by 1 over 7. Okay. Whoops, row 2. And we're going to put that into row 2. Okay. Remember, your goal is to make this 7 into a 1. So the first row is going to stay exactly the same. And I'm just going to make it a little smaller so I don't have to go to another screen. 0, and then 1 7 times 7 is 1, and then 1 7 times negative 4, that's negative 4 over 7. Okay. Don't try and put it in your calculator and get a decimal, just leave it as a fraction. You can reduce it to great, if not, then just leave it alone. And then negative 26 divided by 7, and negative 26 over 7. Now, the last row we did not do anything to. Now, 99% of the time when you do these problems, you're going to not get fractions as your final answer. What that means is that you can, you'll be able to, like everything should work out at the end. You should end up with an integer value. So, even though we're working with fractions right now, they'll probably disappear when we get to our final answer. So now we have the 1, so we're good with that. Our next step is to get that 0 where the 4 is. So we're going to take 4 times row 2, and we're going to subtract row 3, and we're going to put that into row 3. Now we're going to write out the first 2 rows because we're not changing anything. So 0, 1, negative 4 over 7, negative 26 over 7. Okay. Now, so now we're going to do 4 times row 2 minus row 3. So 4 times 1 is 4 times 1 minus 4 gives us our 0. Now this is where it gets a little fishy, and I do suggest you use your calculator, especially using alpha y equals enter to make a fraction. So we're going to do 4 times, make a fraction in your calculator. We're going to do 4 times negative 4 over 7 minus negative 13. Now you'll be able to get a nice fraction of 75 over 7. Okay? Once again, do not use decimals, because if you use decimals, you're going to be rounding, and rounding is bad because your answer won't be perfect. Now we're going to do the same thing. 4 times, make a fraction in your calculator, and put negative 26 over 7, and then subtract negative 122. You'll be surprised, it comes out to be 750 over 7. So now we've gotten to the 0 here, so we're good with that. Our last step is to get a 1 here. So now I have 75 over 7. Now this is where it's important. You need to remember we are now going to multiply the third row by the reciprocal, 7 over 75. Now this may seem like, oh my gosh, a really horrible thing. But what will happen is, so we're doing 7 over 75, R3, putting that to R3. We're going to end up with, and I'll just put it right here for us, the first row is going to stay the same. The second row is going to stay the same. And the third row, that's the one that's going to change. Okay? And if you multiply by the reciprocal, you're going to end up with a 1 here. And then in your calculator, you're going to do 750 divided by 7 times 7 over 75, and you'll end up with 10. So the numbers worked out. So now we have our, remember, this is x, y, and z. Z is going to be 10. Now at this point, we're only doing Gaussian elimination. And sorry about that, I'm going to have to redo this. We're only doing Gaussian elimination, meaning we're going to do back substitution to solve for the rest of this. So the second equation right now is y minus 4 over 7z equals negative 26 over 7. And if you put this in your calculator, you can easily figure out what it is, because we know z is 10. Okay, and if you solve this equation, even though it's sort of ugly, you're going to be able to figure out that it's going to be, sorry, my handwriting's a little gross. You'll get y will be 2. Okay, and just multiply these together and then add the result over to the other side. Okay. So now we have y at 2, z is 10. Now we go to that top equation, is going to be x plus y minus z equals negative 13. So x will be what we're looking for. Y is 2, and z is 10. And if you work this out, you should get x is negative 5. So our final answer is negative 5. 2, and 10 for x, y, and z. Okay? So when you're plugging it in, you can check to see that each one works, and it's really quick to throw it in your calculator. Okay? If you have any questions or comments, you can feel free to reach out to me. Other than that, good luck.